Okay, thank you for watching the Iea demo video. Before I show the demo, I'd like to take a couple minutes to explain what is IEA system. So IEA stands for Intelligent Engineering System. If you want to learn more about this project, you can go to our research website, iea.ec.ucsb.edu. And so what is the Iea? And let's give you an example. Let's think about the Iea system in the context of a yield engineer. So if you look at what yield engineers does daily, basically you have to think about production and test flows. So typically in the manufacturing of semiconductor products, you go through this manufacturing process, you produce a wafer, then you go through these multiple stages of testing. For example, class pro, wafer pro, final test, burning, and so on and so forth. So there's basically two types of data. One is the production data, the other is test data. And in the company, for example, today all the data are stored in the cloud, and then there's an interface you can access those data locally, and an engineer basically use that interface to watch what happened in the production and in the test flow. So, for example, when you look at those data, you may see a yield issue. Then what a yield engineer is supposed to do is go through, look at the data and run through this maybe very complicated analytic workflow, right? And through this workflow, and he or she may discover some interesting finding, and then they would compile this interesting finding into a PowerPoint presentation, and then bring that PowerPoint presentation into a meeting for further discussion. So, so in that sense, what is the intelligent assistant really mean? It actually means a system that can perform autonomous execution. So it's an autonomous system that can execute such a task. And so what is the IEA? So IEA is actually an environment allow us to construct such an autonomous system. So we call this we call IEA a concept-based workflow programming environments. For example, what does that mean? So if you look at the analytic workflow, basically it can be described, like give you example here. Like for example, you can see the first is if you see a year excursion, you enter the context of this particular year excursion for analytics. Then you basically select low yield lots, and then you perform correlation analysis. If you see the correlation trend, then you enter the context of that trend and then maybe you do some sort of wafer pattern analysis here. Now you notice that there's a couple of concepts here associated with the if statement, and marked color as in orange. And in order to enable autonomous execution of such a workflow, you really need some sort of automated way to decide on those concepts. Okay, so basically you need this data-driven concept recognizer for these 5 concepts I'm listing here. And if you have that, then you'll be able to program this workflow and to enable autonomous execution. So basically, Iea is such an environment, and you allow you to do concept-based workflow programming. So Iea is, as I mentioned, is this really this concept-based workflow programming environment to allow us to construct this autonomous executable workflow. And typically Iea system will comprise 3 basic components, such as there's an API for workflow construction to describe what the workflow is supposed to do, and then there's a library of concept recognizer, and basically this is based on analytic tool and machine learning models, and then of course there's a data processing and analytic tools component. And during the autonomous execution, the workflow will of course evolve the tools and get some sort of process result, and if you need to interpret of this process result, we'll call the concept recognizer in the library and then get back for the decision. Okay, and now let's start the actual Iea demo. Thank you. Okay, now we enter the actual demo sections. As you can see on the left, that is the Iea dialog window, and there's a circle there, and when the system is online, you will see the circles moving. On my right-hand side, you can see there's a working folder. Now it's empty, but at the end of demo, I will ask the system to create a PowerPoint presentation, and you'll see the PowerPoint file pop up in this working window. All right. So now let's start the demo. Hey, Iea, are you online?
Yes, I am here. How may I assist you?
How are you today?
I am fine. Thank you.
Do you recognize my login?
Yes, Jay. How may I assist you?
No, this is not Jay. This is Dr. Wen.
Ah, sorry, Dr. Wang. How may I assist you?
I'm doing a presentation here and need a little bit of your help.
Of course, anything I can do for you.
Do you remember I asked you to watch the production line of MP66?
Yes, I was watching the production line MP66 while you were away.
Did you observe anything abnormal, like an anomaly?
Yes, I found a yield excursion in the production. Would you like me to show you the yield excursion?
Yes, of course.
I saw 5 recent lots with yields substantially lower than the average yield in the last couple of months. I'm showing these 5 lots as a yield plot in the display window on the right.
Can you read the first 2 results for the audience?
Of course. The first lot DX 71,247 has a yield that is 22.5% below the average, and the second lot DX 71,521 has a yield that is 21.0% below the average.
Please show me the same plot using a wafer view.
Sure, I am now displaying the same yield plot based on wafers.
Can you also show me a stack wafer plot for those lots?
Yes, I am now displaying the low yield lots, where each lot is shown as a composite wafer.
Okay, did you find any relevant wafer pattern in those lots?
No, I did not. I'm showing you majority of the wafer patterns from those lots in the display window. As you can see, there is no systematic pattern in those lots.
Oh, okay, I see. But did you find any systematic pattern at all?
Yes, I have found failing edge patterns. I'm showing them in the display window, but they only appear in the high yield lots.
Okay. By the way, did you look at the yield from the perspective of a test bin?
Yes. I'm showing you a histogram based on the yield loss from the top 10 test bins. As you can see, test bin 44 has the largest yield loss, and accounts for 16.5% of the total yield loss.
Did you perform correlation analysis on the process parameter for test bin 44?
I did perform correlation analysis on the process parameters, but did not find any correlation coefficients above 0.5.
Okay, I see. But did you see other trend associated with the process parameters?
There are 2 trends that I thought were interesting. I'm showing them in the display window now.
Please elaborate.
Of course. The first trend shows a larger process parameter value tends to have a higher yield loss. The second trend shows the opposite for a different process parameter.
Great. Is any other findings you want to tell me about?
Yes. In addition to analyzing the process parameters, I also analyzed the testers and I found something unusual there.
What is unusual about the tester?
Well, parts in test bin 44 are screened by 3 testers. But tester C68532 has significantly more fails than the other 2. I'm showing you a box plot to illustrate this issue.
That is good.
Thank you, Dr. Wang.
Is anything else you want to report today?
Yes, I was also watching the production line for CP90 and found a yield-related issue.
Please explain what is the yield issue.
I am now showing you the yield issue I found in the display window on the right.
Please elaborate.
Sure, the recent yield for CP90 is exhibiting large lot-to-lot fluctuations. This is causing the average yield to be lower than the expected yield.
Okay, could you show me the yield loss histogram according to the test bins?
I'm showing you a histogram based on the yield loss from the top 10 test bins. As you can see, test bin 33 has the largest yield loss, and accounts for 30.2% of the total yield loss.
Did you find any interesting analytic result?
Yes, I have found a potential issue with production tools which can be contributing to the yield fluctuations.
Okay, show me which production tool you are talking about.
I found 2 production tools which can be contributing to the yield fluctuations. They are CS2T1 and CS2T2 found in stage CS2239YLM.
What is the potential problem with the tools?
As you can see, bin 33's yield loss are higher for the lots produced by CS2T1 and CS2T2. I have also found another trend using composite wafer analysis. Would you like to see the results?
Yes, go ahead.
I found that for bin 33, the 2 tools CS2T1 and CS2T2 both have a higher yield loss, and both suggest horizontal striping patterns under the composite wafer view.
Did you find any other results?
After completing the entire analytics suite for CP90's yield fluctuation, I did not find any additional interesting results.
Okay, could you summarize our conversation today into a PowerPoint presentation?
I have compiled a PowerPoint presentation and saved it under the working directory. Is there anything else?
No, thank you. Thank you for your help today.
Thank you, Dr. Wang. Hope to hear from you soon again. Have a pleasant day.
So now, let's open the PowerPoint presentation. So you can see the date is September 3rd, and it's around 10:30 in the evening now. That's when we're just recorded. So if you scroll down the PowerPoint presentation, you can see the PowerPoint presentation basically record all the plots that during our conversation. All right. Okay. Thank you for watching this demo.